Hello friends, today I'm going to show you how I solved the move zeros. Feel free to comment, and if you have suggestion to improve this, please do that. So what is the problem? So the problem statement is: given an array nums, write a function to move all zeros to the end of the while maintaining the relative order of non-zero elements. So what it says is we have zeros and non-zero numbers, and all we need to do is we need to maintain the non-zero elements order the way they came into the array, and move all the zeros to the end. So for example, 1 came first in order of the array so we moved it to the first position. Similarly, 0 we ignored, and then 3 came and we moved 3 at the second position, and after that 12 came, we moved 12 to the third position, and move all the zeros to the last position. So all the both the zeros are like same, so we don't even care like how we have placed the zero or what is the logic we can use to add those zeros at the end, because all we care is 1 3 12. So how to do that? So the trick that I have used here is uh, this. So what I did is I used zero pointer, like I use zero pointer to maintain where I should be placing my non-zero number. So even though it's says zero pointer, it means that this is the place you feel free to replace it, because all the places which is like containing zero, even if we overwrite, we don't lose anything. So this is how I started. Like we are going to use two loops. So we are not going to use for loop inside a for loop. It will be there's just a two loops. And the one of the best thing about this trick is we are not using any additional array space. We are not copying anything to the another array space and then again replacing it back with the original array. So we are using the same array. It's like in place replacement. So let's see how it goes. So when we start loop 1, you have I equal to 0, and 0 pointer is pointing to the index 0. So we compare like what is the value of 0th index, which is num of I. It is 0, so we don't care, we are not going to do anything about it. Then in the iteration 2, we saw okay, in the second position we have 1. So what we did is we replaced um, the location, like 0 num of 0 pointer, which was earlier 0, and with the non-zero element, and increment the 0 pointer to 1. So now 0 pointer is pointing to this location. So since we have already taken care of 1, now we don't have to worry about what goes here, because the 1 is safe here, and 0 pointer is pointed to this location. Now I equal to 1. So now next iteration, this is pointing to a 0, so we don't care, we will move on, and 0 pointer will remain as this location only. The next location is still pointing to 0, so next location is like this, I equal to 3. Now 3 is non-zero number, so what we need to do is we just need to replace with the 0 pointer and move on. So this is what we did, like 3 is here and 0 is still there and 3 is still here, which we are going to take care of it later. And then next iteration same way, now it's 12, and 12 what we did is this is the 0 pointer in the previous iteration, so we replace that location with the 12 and move the 0 pointer to 4. So now what is happening is we are left with these two numbers, and they're not 0, which is the requirement of this problem. So what we are going to do is we'll start the next loop, another loop, and that loop will be initialized with 0 pointer. So 0 pointer will be 4, which is this location, and all we do is we'll go from the 4 to the end of the array, and we replace these elements with just with a plain 0, and we are just will be done. So coming back to the code, which will be the same thing. So as you see, I have started with int 0 pointer with a 0, for loop from 0 to end of the array, and if num is not equal to 0, so we are replacing the current element with the uh, with the 0 pointer location, and we increment 0 pointer plus plus, and at the end we might left with something which is supposed to be converted into 0, so we start from there and we just simply replace that location with 0 0 0. Yeah, that's it. Thank you.